In this problem, we are given a frequency distribution of GMAT scores. Let's take a moment to read through the problem. The best way to approach these word problems in statistics is to read through the problem first, learn what information is being given to you and what you are being asked to do. Then read this problem a second time in more detail. So this will be our first read. Let's just read it for a moment. Okay, so now let's do our second read. Now that we understand a little bit about what we've been given in the problem text, let's read it more detailed now. Let's think of ourselves as detectives and we are searching for clues in the problem, clues and bits of information to help us identify what problem-solving techniques we will use. So as you notice, I've highlighted some areas in red, made some red marks. That's a very good idea if you have text where you can do that, or take notes, whatever you can do to give yourself summaries of what was given in the problem. So we know that we are being asked to find percentages and we have a frequency distribution. So the first thing as I'm reading, I noticed that yes, the GMAT scores are our numerical variable. So that's our variable of interest. And we will be constructing a frequency distribution to help us visualize that numerical variable and the pattern of frequencies of the observation. So in this particular case, the observation will be a summary of how the different scores occur within a sample of scores. So our sample size is 50 applicants. So if you were taking notes, you would want to write, n equals 50. Sample size is always represented with a lowercase n. So we are told that we have a frequency distribution and it was constructed for us. Now a frequency distribution involves counts. If it were called a relative frequency distribution, we would be working with percentages. So we are given counts. Let's review a few terms. Frequency can be thought of as counts. Frequency is the number of times the observation occurs in the data. So in this case, the number of times the applicants fall within certain classes of scores. Number of times these scores appear. A distribution of a variable is the pattern of frequency of the observation. In this case, it would be a summary of how the different scores occur within a sample of scores. So within our sample of 50 applicants, how do the different scores occur? What's the pattern? So the class intervals were created for us. Whenever we group data by classes, we have grouped data. And that makes the data easier to work with. Instead of this long list of scores that we're trying to make sense of, we have them neatly grouped into classes. And the number of classes will be determined by how large or small your data set is and how many classes you want to summarize and organize that data set. You don't want to have too many classes because then it's confusing, but you don't want to have too few classes because then you really can't see much because everything's grouped into these few classes. So you might even get a rectangle if you were graphing it. Okay, so a frequency distribution helps us to visually display and organize the frequencies or the counts. Frequency distributions are typically represented by a table or a graph. We will make a table for this problem. Later on, we will make a graph for other types of problems. Frequency distributions can be used for categorical variables or numerical variables. When we constructed bar charts, we had frequency distributions for categorical variables. Now we are working with numerical data, and so our frequency distributions will be used for numerical data, and we will represent them most likely by a histogram. A histogram is a graph used to represent numerical data. So a class is a group of data which is related by some user-defined property. So for example, these scores. It's related by a range of scores. So class would be a range of values. So an example would be ages of people, and we can create classes for the different ages, for the teens, the 20s, the 30s, the 40s, etc. And we can put in numerical values for the upper and lower class limits. So this is the lower class limit, the 450, and this is the upper class limit, the 499, and that each class has a lower limit and an upper limit. So we are given this information about the classes, and then we are also given some information about counts. So we know that 2 applicants scored in the interval 450 to 499, and 16 applicants scored in the interval 500 to 549. So to help us visualize this, it would be easier to make a table. This is a little bit difficult to discern from the text, so let's just start. These are our rough notes from the problem. And so we know that frequency distributions, we have frequency tables. They're represented by a table. So we'll create a table for this problem because we are not asked to create a graph. So it's a table. We'll represent the frequency distribution using a table. So these are our notes from what we gained by reading the problem text. So if we take it a step further and create our table. So our variable is GMAT score. These are our class limits. These are our classes. These are our frequencies, our counts. So we've constructed a table based on the information we were given in the problem text. Notice that some classes were missing. We weren't provided those. We could determine what they are based on the information we were given, but there is no need because the problem doesn't ask us to solve problems related to all of the classes, just specific ones. And notice we got the 50 here from our sample size, which we were given in the problem, 50 applicants.